Okay, so today we're going to cover section 8.2 over integration by parts. I alluded to this idea a little bit on Friday. Some of you are asking questions about how you could split up an integral if your functions are multiplied together. And I told you that the answer is going to be related to this, integration by parts. And it's related to reversing the product rule. So the product rule, you remember from calculus 1, lets us take the derivative of two functions that are multiplied together. And what we're going to figure out in this section is some way to reverse that rule. So remember, integrals are the opposite of derivatives. So if we want to figure out some sort of integral rule for functions being multiplied together, this is the rule that we need to reverse somehow. And here I've just written it out. So the derivative of two functions, u of x times v of x, is equal to the derivative of the first function, u prime, times the second function, plus the first function times the derivative of the second function, v prime. And what we're going to do is a little bit of rearranging, and then we're going to integrate both sides of the equation. Okay. So what I want to do is keep this term on one side and move this other term to the same side as this expression. And I'm also going to reverse the order a little bit. So on the left side, I'm going to write the u of x v prime of x. And then I'm going to write the left side. So we're reversing the order a little bit. This gives us the dx u of x v of x. And then we'll get minus this. So like I said, all I've done is I've moved this to the same side as that expression, and then I swapped around the order. So now this term, u of x times v prime of x, is on the left side, and then this expression is combined with this one, and we had to subtract to move it to the same side. And the next step is to integrate both sides of this. So on the left, we just have the integral u of x times v prime of x. And then we'll tag on the differential dx since we're doing an integral. And then, well, we're going to take the integral of a derivative. That means this derivative is going to disappear because the integral is the opposite. So we just have the functions by themselves. We've gotten rid of the derivative, and then we subtract, and we have to integrate this term. It doesn't have an integral, it doesn't have a derivative that just cancels off the integral. So we need an actual integral here. And this is the rule for integration by parts. Let me just put a note here that the derivative cancels. And that's the fundamental theorem of calculus, the kind of grandiose name for integrals canceling derivatives. Okay, and let me just write this again, maybe a little bit cleaner. The integral of u v prime dx is equal to uv minus the integral of u prime v dx. And this is the shorthand way that you'll usually see the rule written down. In reality, u and v are all functions, so we really should have the argument x, the variable inside of them, but it just takes up more room. So you'll usually see it written out this way. So you're probably wondering how, starting here, so we have two functions multiplied together, how ending up with this right-hand side, which looks more complicated than what we started with, you're probably wondering how this is helpful. And I think you're right to question it, question the wisdom of this, and we'll see how that works in the examples on the next page. But before we get there, I want to give you a big warning in all caps and then a couple hints for when you're working on these problems on the homework. So I know that some of you want to do what I'm about to write. So if you start with this integral, I know a lot of you want to do this. Just split it up into two separate integrals and just multiply the two integrals together. But don't do this. Don't ever do this. This is bad. And it will end in sadness when you miss a question on an exam. So let me go ahead and cross this out so it doesn't look like I'm writing it as something that you should do. So never do this. It won't ever work out nicely. So do this, integration by parts. Don't do this. And here's a couple hints for when you're doing integration by parts. So the thing to notice here is on the left-hand side, we start with a function times the derivative of a function. And on the right-hand side, we end up with a v. So we started with a v prime and we end up with v. That means we had to find an antiderivative for v in order to get this. And we started with u, and you'll notice a u prime over here on the right side. So we had to take a derivative. And those two observations lead to a couple hints when you're doing these. First of all, since we're going to take the derivative of u, since you get to pick u when you're working through the problems, this is something like a u substitution, your choice of u should have an easy derivative. And since we're going to need to find an antiderivative for v, we need to make sure we choose v so that, well, we can actually find that antiderivative. It shouldn't be a lot of work. So v prime should have an easy antiderivative. So let me underline anti there, and maybe I'll put quotation marks around easy, since this is an opinion, of course. Something that looks easy to one of you might be challenging to someone else. So since this is something like u substitution, we're going to look at an integral and we have to pick what u and v prime are. There isn't a rule for choosing u and v, just like there isn't a rule for choosing u in a u substitution. Instead, we have to follow these hints and a little bit of experience. So working through problems will give us that experience. And this, hopefully, these couple hints will get us started. Are there any questions before we try some examples? So let's go to example 1, and we'll look at this function, x times sine x, and we should think, first of all, do we know any rules to do this integral? So let me write that question. So this is what you should think when you're doing your homework. Do I know any rules that would let me do this? For this kind of integral. So do I have any rules for powers of x times trigonometric functions? What do you think? Do we know any rules? Remember that table of rules that we've learned? What was it, table 8.1 in the last section? Were there any rules that looked like this one? Okay, so hopefully you thought about it and you decided that, well, you don't really know any rules for this one. And this is a little bit like the last example from 8.1 where we had an x to the 4th times sine x. That one we were able to do because we had limits of integration, minus pi to pi, that let us say that the answer was just 0 because we were looking at an odd function. But this one, we can't use that to help us because it's an indefinite integral. There isn't a shortcut. Instead, we'll have to do integration by parts. And maybe I should show that to you again. Let's see, where's my sheet? So remember, we're looking for two functions being multiplied together. One of them is just a function that we're going to take a derivative of. The other is a function that we need to take an antiderivative of. So looking at these two functions, which one has an easy derivative, x or sine x? Well, let's think about it. The derivative of x is the number 1, or the function, the constant function 1. The derivative of sine x is cosine. So it seems like if we want to make the problem easier, if we want to simplify things for ourselves, it would be easier if we took the derivative of x, because, well, we just get the number 1, and that's easy to deal with. So let's write that down. We're going to pick u to be x. And since we're looking at u times sine x, and we want to use integration by parts, where we have two functions being multiplied together, that means v prime is going to be what's left over. It has to be the sine x function. So what is u prime, the derivative of x? Well, we just talked about that. It's 1. This one is a little bit more challenging to think about. We start with v prime. We say that's equal to sine x. What's an antiderivative for sine x? Anyone? And I'll just wait a second here until someone answers.
Is it negative cosine?
Right, it's minus cosine. And when we're doing integration by parts, we're not going to worry about putting a plus c here, because we're going to put a plus c on the end of our integral when we're done. So we don't have to worry about it at this point. So now we've picked u and v prime. We've identified u prime and v. What we need to do is look at our rule for integration by parts and just write it out. Maybe I'll write it again here on the paper, just so that it's handy. So we're going to start by writing u times v. So that'll be x times minus cosine x. And then we have a minus sign. And this minus sign is actually very important. Don't make the mistake of putting a plus sign there instead of a minus, because that will lead to an incorrect answer. So we need a minus sign, and then another integral. We take u prime, that's 1, and multiply it by v. So that's minus cosine of x again. Maybe let's box this down here, just so that it's set aside from the rest of our work. And clean things up a little bit. We have x times minus cosine. Let's just write that as minus x cosine of x. And then in the integral, we have a minus sign, or 1 times minus cosine x. So what we could do is pull this minus sign to the front, pull it to the outside, and 2 minus signs give us a plus sign. And then the only thing left inside of the integral is now cosine. So I know some of you are probably skeptical, as I mentioned, that the rule for integration by parts was very helpful, because it seems like we started with something simpler than what we ended up with. But in fact, if we choose u and v prime carefully, according to those hints that I gave you, what we're going to end up with is something that's actually easier to integrate. Because this, we don't have to worry about at all. It doesn't have an integral anymore. And the piece that's underneath or inside of the integral is now easier, simpler to take an integral of. Here we had an x times a trig function. Well, we got rid of that x. We just have cosine. So someone tell me how to finish off. What is the integral of cosine x?
Sine x.
Good. So we just have a sine x. And then this last step is where we put the plus c on our integral. So to show that we could add any constant to this answer and we would get a different antiderivative. So any questions over that first example? Okay. So if there aren't any questions, let's move on to another example. We should have time for at least this one more today. So now I want to take the integral of the natural logarithm. So we know how to take the derivative of the natural log of x, but you might think back to all the rules that you know for integrals, and well, you won't think of one for this one because we haven't learned one yet. That's because we need this idea of integration by parts in order to figure it out. This one's a little tricky though, I think you'll agree, because integration by parts, our whole motivation was to try to integrate functions that are multiplied together to reverse the product rule. But it's not clear that we have anything being multiplied here. We just have the single function natural log of x. And this is where a little trick comes into play. If I didn't tell you the trick, you would have a hard time guessing it. What I'm going to do is think about just having an extra number in here. Just multiply by 1. So I haven't changed anything. We multiply by 1, doesn't do anything. But it does give me another option for my function v prime. I'm going to pick u to be the natural logarithm of x because it has an easy derivative. It's just 1 over x. And v prime is going to be this extra function that I added in, the constant 1. And this has an easy antiderivative. The antiderivative of 1 is, of course, just x. And if I make this choice, we're going to be able to finish off this integral. So maybe put that in the box, set it aside. Like I said, this is a little trick, adding this extra multiple of 1, and it might come in handy on your homework in a couple spots. So it's something to keep in mind as something that you could do if you need it. And I have the rule written up here that we're using integration by parts. So remember, I need u times v. That'll be log x times x. And then we'll subtract the integral of u prime, that's 1 over x, times v, which is just x by itself. And, well, what happens here? We have a 1 over x times x. Those just cancel each other. That goes away. So we have this first expression. I'm going to put the x in the front to make it look a little neater. And then my integral, we're just integrating 1. 1 times dx. So what's the answer? Well, what is this integral? Someone? What's my antiderivative for 1?
Is it x?
Right, it's just x again, like before. So we have x log x minus x. And then we'll need to add a constant since we're looking at an indefinite integral. And that's it. That's how you integrate natural log. You get an x log x minus x plus a constant. And if I were you, I would add this maybe to my memory bank of integrals formulas that I try to remember. So remember, we had that big table of integral formulas. You might want to at least mentally add this to that list, that table. It's a fairly important one. And it also has this neat little trick. This neat little trick for integration by parts that comes in handy occasionally. So you should remember that as well. So are there any questions over that problem? Okay, so since there aren't any questions and it looks like we only have a couple minutes left in class, this is going to be our stopping point for today.